Okay, so in this lesson we're going to talk about compound inequalities. So this will be part one. Now let's kind of review inequalities. So we're going to look at this example, and remember this is a review. Suppose you want to solve this inequality. Because we had 2x minus 1 is, let's say, less than 5. All right, so notice this inequality, you want to solve this inequality. You want to find the solution. So you want to find out what real numbers multiplied by 2 and then subtract 1 will be less than 5. What real numbers will make this left side, this expression, less than 5? All right, so what you did in previous lessons was you used the addition property and multiplication property of inequalities. So basically you added 1 to both sides. And so when you combine like terms, you get 2x is less than 6. And then to get the variable by itself, right now you're multiplying by 2, the coefficient's 2. The inverse operation of multiplication is division, so you can divide both sides by 2. And so remember, when you multiply or divide both sides of an inequality by a negative number, you got to reverse the symbol. But in this case, I'm just dividing by a positive number, so I don't reverse the inequality symbol. So I get all the solutions, all the real numbers that will make this inequality a true statement will be any real number that's less than 3. And so what we did was we also graphed the solution. So you can't list the solutions. There are an infinite number of solutions here. So all you can do is graph the solution set. So this is 3. Since there's no equal sign, since 3 is not a solution because 3 is not less than 3, so 3 is not a solution, put an open circle, and I want all the solutions that are all the real numbers that are less than that. So I'm going to go to the left with an arrow. Okay, so that's what we talked about in the previous lessons. Now also the interval notation, you usually asked to write this in interval notation. So since the arrow is pointing to the left, implying negative infinity, you can say negative parentheses negative infinity comma 3. Since 3 is not a solution, you're going to use parentheses on 3. Okay, so now notice this is a simple inequality. So let's call this a simple inequality. Okay, now what we're interested in though are compound inequalities. So a compound inequality is an inequality statement where we have 2 or more inequalities joined by the words and, or. So we're looking at the words and or the word or. Okay, so let's look at an example and let's see what this means. Okay, so suppose we want to solve this compound inequality. All right, suppose we had x is less than 1 and, notice the word and here, and x is greater than negative 3. Now, notice that this lesson is just on the basic concepts. So in the next lesson, we're going to look at compound inequalities involving inequalities of this nature. But we're just going to look at these inequalities where the variable is already by itself. So that way we can understand what does the word and do or mean, and then what does the word or mean. Okay. Now, to solve a compound inequality, in this particular case an and statement, what you're saying is this. So if this was just a simple inequality where this wasn't there, you would just graph all the solutions, all the real numbers that are less than 1, just like we did this. All right, and that would be the solution to this. All right, but this is an and statement. So what we're saying is this: I want to find all the real numbers that are less than 1. And at the same time, I want those real numbers to be bigger than negative 3. All right, so let's say that again. I want all the real numbers that are less than 1. And at the same time, those numbers have to be bigger than negative 3. So for example, is let's say negative 4 a solution? So is negative 4 a solution? All right, well, is negative 4 less than 1? Yes, negative 4 is less than 1, but you got to ask yourself, is negative 4 greater than negative 3? The answer is no. Negative 4 is not greater than negative 3. Negative 4 is less than negative 3. So is negative 4 a solution? No. Okay, so remember what we just did. All right, so what this right here was showing you was that in an AND statement, this number has to make this true and this true. Okay, so again, whatever the solution is has to be a solution to this and a solution to this. Okay? All right, now the way you want to do this, the way you want to solve this, especially when it starts looking like this, the way you want to do this is you're gonna once you get the variable x by itself, you're gonna graph each inequality separately. All right, so basically we're gonna graph this one first. So let's graph the solution to this one. All right, so let's do that. So that's the way you're going to do this. You're going to graph each one, and then you're going to graph the final solution set. Okay, so x is less than 1, so this is 0, and this is 1. I'm going to put an open circle on 1, and I'm going to shade in all the numbers to the left. Okay, so that's the graph of the solutions to that first inequality. All right, now you're going to graph the next one. So let's graph the next one. X is greater than negative 3. So again, whenever you graph both of them, make sure your numbers are aligned. Otherwise, you're going to mess up with your final solution. So make sure they're aligned. See how I aligned the zeros? Okay, now let's graph this one. Now we're graphing this one. X is greater than negative 3. So negative 3 is on the left side of 0. Okay, there's no equal sign, so I'm using an open circle, and I want to shade in all the real numbers that are bigger than negative 3, that are greater than negative 3. Okay, just like that. All right, now let's talk about the word and. So here's how you're going to use the word and. So remember, I want to find all these solutions that are less than 1 and at the same time greater than negative 3. So if you look at this, remember negative 4, which is here, was not a solution because negative 4 was not shaded here. So, and the same thing for 2. So is 2 a solution? Is 2 a solution? Well, 2 is bigger than negative 3. See, 2 is shaded here. I'm sorry, here. See, this is where 2 is. 2 is shaded here. But is 2 shaded here? So is 2 less than 1? The answer is no. Okay, so the answer is no. And then suppose I asked you, is 0 a solution? Is 0 a solution? Yeah, 0 is less than 1. Here's where 0 is shaded right here. And 0 is greater than negative 3. So here's 0 here. So 0 is shaded on both of those. So I want you to notice, so this is yes. So I want you to notice this. So when you see the word and, you're looking for where those two graphs, see the solutions are right here. So it's where those two graphs intersect, where they overlap. So when you see the word and, you're looking for the word, you're going to think of the word intersect or overlap. Okay, intersect or overlap. Okay, so again, as we go through this, you're going to graph each of these individually, and then you're going to look to see where they overlap. And so your final, so your answer, the way you're going to write this is for the graph. This is your answer. So remember, you're solving this, so you're graphing the solution set. This is not your answer. This is the work you do to get to the answer. Okay, keep that in mind. All right, so all your solutions then are going to be between negative 3 and 1. That's where those two graphs overlap. So you're going to say negative 3, 1, open circle, because there's no equal sign here on either one, and then you shade between them. So there's your solution. There's the graph of your solution. So remember, any number between negative 3 and 1 is a solution. So that's your graph. Remember, this is your work. So don't put that as your answer. This is your answer. And then interval notation. Okay, so the interval notation, you're going to say parentheses, negative 3, comma, 1, parentheses. Okay, so that was, and an example using an AND statement. All right, let's do another one. Okay, so let's call this one number 1, and then this will be number 2. All right, so number 2, let's suppose we had, let's say we had x is less than or equal to 4, and x is greater than negative 1. Okay, so let's look at that one. All right, so x is less than or equal to 4, and x is greater than negative 1. All right, so again, we're trying to solve this compound inequality. It's a compound inequality because you have these two inequalities joined by the word and. So you want to solve this compound inequality. All right, so the variable x is by themselves on each of those. So you want to find that all the real numbers that are less than or equal to 4, and at the same time, you want those real numbers to be bigger than negative 1. All right, so the process you're going to go through is you're going to graph the solution to each one individually. So we're going to graph each one individually. So this is your work right here. This will be your work. So you can graph x is less than or equal to 4. And so here's 0. Always put 0 on here so you can align these. And then 4 is here. And then since 4 is a solution because of the equal sign, you're going to use a closed circle. And you're going to shade in all the real numbers less than or equal to 4. All right, now over here, I'm going to graph x is greater than negative 1. So again, align your number line. So this is 0, negative 1's here. Since there's no equal sign, negative 1 is not a solution. So I'll use an open circle, and I want to graph all the real numbers that are greater than that. All right. Now, remember in the AND statement, I'm looking for where those two graphs intersect. So they intersect or they overlap between negative 1 and 4. So your answer for your graph, you're going to say between negative 1 and 4, open circle, closed circle, because 4, you have an equal sign here, so 4 can be a solution. 4 is a solution, rather, and you shade in between them. Now, if you were using parentheses and brackets, you'd say negative 1, 4, parentheses pointing to the right, bracket pointing to the left, and you shade in between them. All right, now the interval notation, so you're going to say parentheses, if you use either one of those, parentheses, negative 1, comma, 4 with a bracket. Because negative 1 is not a solution, but 4 is a solution. All right, remember 4 is a solution because 4 is less than or equal to 4, and at the same time 4 is bigger than negative 1. Negative 1 is not a solution because even though negative 1 is less than or equal to 4, negative 1 is not greater than negative 1. Negative 1 equals negative 1. All right, so that was that one. All right, now let's look at number 3. Okay, number 3, suppose you had x is less than, let's say, 5, and x is less than or equal to 2. So x is less than 5, and x is less than or equal to 2. Okay, so again, we're going to graph each one individually. So this is going to be your work. So you're going to graph the first one. So here's 0, here's 5, let's say, and then I want to shade in all the real numbers that are less than 5. So I'm putting an open circle, and then to your left. Okay, now the next one, x is less than or equal to 2. Again, align your numbers. So here's 0. Now, be careful where you put 2. Don't put 2 over here because 2 is not bigger than 5. So you got to make sure your number line is aligned. Otherwise, you're going to mess up with your final graph. So 2, let's say, is here. All right, closed circle, going to the left. All right, now notice where the two graphs overlap. They overlap all the way from negative infinity. See the arrows? So negative infinity all the way to, and then 2 is where they stop. All right, so then your answer to the graph So here's 2, closed circle because 2 is less than 5 and 2 is greater than, I'm sorry, less than or equal to 2. And then you're shading in everything to the left. So there's your graph. That's your solution. So the solution to this compound inequality would be any of these numbers, anything from negative infinity to 2. So your interval notation, I can say negative infinity, comma, 2 with a bracket. Okay, number 4, let's get another and statement. Number 4, suppose we had x is, let's say this time, greater than negative 2, and x is greater than or equal to, let's say, 3. Okay? All right, so again, your work, you're going to graph each one individually. So x is greater than negative 2. Here's 0. Negative 2 is on the left. Open circle going to the right. So that's the solutions for that first inequality. Now you're going to graph the solution to the second inequality. So here's 0. Here's 3. Make sure you line them. And greater than or equal to, so 3 is a solution, so I'm going to use a closed circle, and then going to the right. So I'm shading all the real numbers that are greater than or equal to 3. All right, and remember, this is an and statement, so and remember means intersection. So let me go ahead and shade this a little bit further. All right, so where the two graphs intersect is what you got to ask yourself, where they overlap. So they overlap from 3 all the way to infinity. So your answer, remember this is your work right here. So your answer, so the graph of the solution set, you're going to say, here, this is 0, this is 3, closed circle, because 3 satisfies this, so 3 is the solution here, and 3 is the solution here because of the equal sign. So closed circle, and then you go to the right. So there's your graph. That's the graph of the solution set. So your interval notation, so you're going to say, you're going to say bracket 3, comma, infinity. All right, number 5. Okay, and number 5, let's suppose we had this. So let's suppose we had x is less than or equal to 6, and x is greater than, let's say greater than or equal, let's say greater than or equal to 8. All right, so x is less than or equal to 6, and x is greater than or equal to 8. So again, I'm trying to find what real numbers are less than or equal to 6 and at the same time are bigger than or equal to 8. All right, so let's do the work. So remember, to find the solution to this compound inequality, you're going to graph each of these individually, and then you're going to look for, since it's an and statement, you're going to look for where the two graphs intersect, where they overlap. So let's graph the first one. X is less than or equal to 6. So this is 0, and this is 6. So since 6 is a solution to this inequality, you're going to shade all the real numbers less than that. So you can put a closed circle and shade all the real numbers less than that. Then we're going to graph the next one. X is greater than or equal to 8. So again, this is 0. And be careful where you put 8. Don't put 8 here, because 8's on this side of 6. So make sure you put 8 in the right place. So let's say this is 8. Closed circle again, because 8 is greater than or equal to 8, because of the equal sign. And then you shade to the right this time, because it said you want all the real numbers that are greater than or equal to 8. All right, now your answer, okay, listen to this carefully now. So if the number line is given, all right, just like this, if the number line is given, all right, so remember in the previous examples, we determined where the graphs intersected, and then on the answer, the graph, we shaded in the solution set to our compound inequality based on where they intersect. Over here, though, if you notice, those two graphs don't intersect at all. They don't intersect at all. Okay, so if on the worksheet or a test, if the graph is there, or if the number line is there, you're just going to put right here, you're going to put empty set. Oops, you're going to say no solution. No solution. You're going to write the word no solution, or you can use the symbol for empty set, which is this symbol right here. All right, now in my math lab, they're going to use probably the symbol. And if there's a multiple choice question, they'll probably use the word symbol. So this symbol would indicate there's no solution. On a test, you can write out the word no solution. All right, so remember these two graphs don't intersect, so there's no solution. Again, in the interval notation, if there's the word interval notation and there's a blank there, just say empty set or just say no solution. Okay, so there's nothing to graph because there's no solution, so you're not going to put anything in the graph. You're just going to say no solution. All right, so that's going to take care of the and statement. So right here, so where I had the word basic concepts, oops, right here, basic concepts, let's just put the word and here. So we're going to, so part one is dealing with an and compound inequality. All right, so remember and, look for the intersection, where the two graphs intersect.